teaching Angelo E. Combustion Quiz number 3, question number 2. Problem. State 1 for dual combustion engine is P1 equals to 1 atmospheric and T1 equals to 60.3 Celsius. Compression ratio is 218. At the end of the constant volume combustion process, the pressure is 7695 kPa. Ratio for cutoff is 1.5 based on the 1 kg cycle of hot air standard with K equals to 1.31. Determine A, the percentage clearance. B, PV and T at each corner point cycle. C, the work. D, efficiency. And E, mean effective pressure. So solving for this problem, again we will need diagram for dual combustion engine. PV. One, two, three, 4, 5. So the givens are P1 equals to 1 atmospheric, or 1 atmospheric for standard is 101.325 kPa. T1 equals to 60.3 plus 273.15 equals 60.3 plus 273.15 equals 333.45 K. Compression ratio is also given at 18, and P3 is 7695 kPa. Cutoff ratio is 1.5. Mass is 1 kg per cycle. Proportionality constant is 1.31. So for A, looking for percentage clearance, which is C. Formula for percentage clearance is RK equals to 1 plus C over C by C equals to 1 over R, which is 1. So 1 over 18 minus 1 equals, by solving for this, we will get 0.0588 or 5.88%. Now B, PVT at each corner on point cycle at point 1. Since we have given PT, well, PT also P1 and P2 is already given, 101.325 kPa, and T1 equals to 333.45 Kelvin. Now for initial volume we will use ideal gas law. PV equals to MRT. So V1 equals MRT over P1. Mass equals to 1 kg. For R is to error not under this We will use this table. R is equal to 0.287 kilojoule per kilogram Kelvin. Now 0.0287. For temperature, one is 333.45. That is Kelvin. Then pressure one is 101.325 kPa. For initial volume V1, we will get, by solving, 0.287, 333.45, 101.325. We will get 0.944 meter cube. That is for V1. Next corner point is at point 2. So at point 2, P2 over P1 equals V1 over V2 raised to K. Since this is also R over K. Now for solving for P2, since we have P1 and we have compression ratio, P2 equals to P1 RK raised to K equals P1 is 101.325 kPa times 18 and K is 1.31. 101.325. By solving for this, we will get 4468.107 kPa. That's for P2. Next is for T2. T2 over T1 equals V1 over V2 K minus 1. Again, compression ratio for T2 equals T1 compression ratio K minus 1 equals, since we have T1 is 333.45, that's Kelvin, times 18 times 1.31 minus 1. T2 equals to, by solving, 33.45 times 18 raised to 1.31 minus 1. 816.893 Kelvin. Or 273. T2. 543.893 Celsius. Next is V2. Since we can VR compression ratio over V1 over V2, we have both V2 equals to V1 over RK. V1 equals to 0.9445 meter cube over 18 equals V2 equals to, by solving, 0.9445. You get 0.0525 meter cube. Now at point 3, since P3 is already stated at the problem 7695 kPa. Also, we have here V2 equals to V3 0.0525 meter cube. Now, one left is T3. Solving for T3, point 3 is T2 over P3 over P2. Now T2 is 816.893 times P3 is 7695 over P2. P2 is 4468.107. Solving for T3. T3 is equal to 816.893. 7695 over 4468.107. T3 is 1406.857.9 Kelvin. Next is at point 4. Since in the diagram P3 equals to P4, then 7695 kPa, then solving for this, T4 over T3 equals to V4 over V3. But V4 is and V3 equals to cutoff ratio, and we have the cutoff ratio is equals to 1.5. Then we can solve for V4. V4 equals to cutoff ratio is 1.5 times the V3. V3 is 0.0525 meter cube. Now V4, by solving 1.5, 0.0525, 0.07875 meter cube. Now we have V4 here. Since we have V4, we can solve for T4. T4 over T3 equals V4 over V3. Now for T4 equals T3 V4 over V3. Since we got T3 as 1406.8579 times the V4 is 0.07875. 0.07875 over V2 0.05 to 0.0525. By solving for this, we'll get to 0.287 Kelvin T4. And last corner is at point 0.5. Here at 0.5, T5 over T4 equals V4 over V5 K minus 1. Also, cutoff ratio K minus 1 over compression ratio or K minus 1. T5 equals to T4 cutoff ratio K minus 1 over compression ratio is RK K minus 1. Then substituting the givens, 0.287 Kelvin. Cutoff ratio is 1.5 raised to 1.31 minus 1 over 18, 1.31 minus 1. Solving for this, we will have the value of 976.777 P5. Solving for P5 over P1 equals to T5 over P1. P5 equals to P1 this is T5 over T1. Substituting 101.325, 976.777 over 333.45. We will get P5 as 296.512 kPa. Now, since here the diagram volume 1 and volume 5 is equal 0.9445 meter cube. Now we're done at B. Now solve for work. Now in work, we will all use the temperatures we got. Let's write it 333.45 K. T2 equals to 86.893. T3 equals to 1406. 1.06, let's 0.0685858 Kelvin. T4 equals to 0.287 Kelvin. T5 equals to 976.777 Kelvin. Now solving for work. C. Work is equal to Q added plus Q rejected. Heat added plus here is heat added, then heat rejected. Formula for but we will find first the constant volume and constant pressure. Now R over K minus 1 equals to 0.287 over K is 1.31 minus 1. You will get 0.9258 kilojoule per kilogram Kelvin. Cp equals to Kr over K minus 1 equals to 1.31 times 0.287 over 1.31 minus 1 equals to 1.2128 kilojoule per kilogram Kelvin. Now, let's divide this. So first we solve heat added. So for heat added, mass times CV T3 minus T2 plus MCP T4 minus T3 equals, substituting the values, 1 kg times the CV is 9258. The temperature is 1406.858 minus T2 is 816.893 plus mass again 1 kg. CP is 1.2128. T4 is 2110.287 minus T3 is 1406.858 Kelvin. Solving for this, heat added is 1399.308 kilojoule. Now, for heat rejected, MCV T1 minus T5, mass is 1, CV is 0.9258, and T1 is 333.45 minus 976.777 equals negative 595.5. Solving for this, 0.9589258 33.45 minus negative 9592 kilojoule. Now, going back to this equation formula, work equals to 1399, which is heat added, 8 minus plus minus 595.952 equals work equals to 800 1399.308 plus negative 595.59592 equals 3.716 kilojoule. Now we have the work. Another question is the efficiency. So the efficiency is work net over QA. Work net, this is also work net 803.716 over QA is 1399.308 both kilojoule. Now the efficiency times 100% is 57.44% or 0.5744. This is D. Now it's the mean effective pressure. Formula for this is VD. We have work net, and VD also equals to V1 over V2 work net. So 803.716 kilojoule over V1. So as we can see here, 0.9445 minus V2. Where is the V2? Here. 0.0525. Solving for this, here, material Q, you will get 901 kPa. There. Thank you.